Good morning, class. Today we're going to talk about the difference between temperature and thermal energy or heat. So the differences between temperature and heat. Okay, to start off, we're going to talk about the three temperature scales. One temperature scale is used all the time and we're very familiar with. The other two, not so much. So the three common scales are Fahrenheit, which we use all the time in America. Very familiar with Fahrenheit. Celsius, which is the worldwide scale used in just about every country except the United States. And then Kelvin, which is used by scientists for extreme temperatures. Now, if you look over here on the thermometer, the Fahrenheit has readings that we are very familiar with. We'll start at the high point of boiling water, 212, work our way down, and we come to body temperature, which we know is about 98.6 typically. Room temperature is usually about 71, 72. Freezing point of water, 32. And it goes all the way down, way below zero. Now for Celsius, different numbers. Water boils at 100. Body temperature is around 37 for a human. Room temperature, 21. Freezing point, 0. So way different numbers. Way different numbers. Here we have more scales here. Kelvin, Celsius, and in Fahrenheit, Celsius. These two are metric. Fahrenheit is English. Kelvin is very popular because it does not have negatives. It starts at 0, which is absolute 0, and works its way all the way up. So very convenient for working with extremely low temperatures for scientists. Kelvin. A little picture for you to enjoy. Okay, we're going to talk about how heat is transferred in the coming lessons. So a little preview here. 3 ways in which heat is transferred. One is by conduction, direct contact, that is. When you touch a hot pan and burn your finger, that's conduction. Radiation is a transfer of heat through empty space. And then convection is the transfer of heat upward through currents. Talk about those later on in a few days. Here's a fun experiment. On the left, we have hot water with red dye. On the right, we have cold water with green dye. You can see that in the hot water, the dye moved a lot faster than in the cold water. Fun experiment to try at home if you can get some hot water and some food coloring. Why does it move so fast? Answer, the molecules are moving super fast, so when you put a drop of dye in there, the dye hits each molecule and spreads rapidly, almost like it's being mixed. Cold water, molecules moving a lot slower, so when you drop the dye in, there's just less thermal energy and there's nothing to really, not as much to bounce off of, and it spreads more slow. Okay, moving on. Thermal energy is the total energy of all particles, the total. So 2 samples can have the same temperature, but not the same total energy because thermal energy takes into account the mass. So if something has more mass, then it's going to have more thermal energy if it had the same temperature. Okay, temperature is the average kinetic energy of the particles. The average, thermal is the total. So average for temperature and total for thermal or heat. So what's the difference? Thermal energy or heat energy deals with mass, has more mass. Okay, temperature. How do we measure the temperature? You know this. We use a thermometer. A thermometer. Most thermometers have alcohol, red alcohol in it, and the liquid expands when it gets warmer and contracts when it gets colder. In the olden days, when I was a kid, the thermometers had mercury, silver mercury, quicksilver. Okay, thermal energy is the total. And not just hot things have thermal energy. All matter has thermal energy, even if it feels cold. Even cold things have thermal energy. In fact, something cold, very cold, can have a lot of thermal energy, even though it has a very low temperature. Thermal energy takes into account the mass. The mass. Okay, here's a cool picture. If you look, beaker A on the left is 100 degrees Celsius and has 50 mils of water. Beaker B on the right, same temperature, twice the amount of water, 100 milliliters, and therefore it has twice the amount of thermal energy. So temperature for both is the same, but the thermal energy is doubled in B. Here's another one. Which has a higher temperature? On the left, you see an iceberg out in the middle of the ocean somewhere. And on the right, we have a cup of tea that's hot. So higher temperature, of course, is tea. Everybody knows that. Everybody in the right mind knows that. Which has higher thermal energy? Well, let me ask you this. Which one has more mass? Answer, the iceberg has more mass by far. Therefore, the iceberg actually has more thermal energy than the tea. We'll finish with a little joke here. What does a bee do when it's hot? Takes off its yellow jacket. I'll have some more jokes coming up because I know you miss my funny jokes and humor. That's it for today. Hope you enjoyed this little screencast, and there'll be more coming up in the near future. So have a great day.